The importance of oral health for the gut microbiome. In today's video, we're going to discuss several factors surrounding how the oral microbiome plays a role in regulating our gut microbiome. We're going to begin by just discussing the scope of the oral microbiome and then chat a little bit about how oral health plays a role in the gut. It's clear, if you think about it, the mouth is effectively the doorway through which all bacteria are going to enter our body. So it's important to kind of look at how oral health is going to play a role in what types of microbes are going to be populating our gastrointestinal tract. We're going to dig into the evidence, see what the evidence tells us about the transmission of oral bacteria throughout the rest of the gut. And then we're going to end by discussing how we can improve oral health. We're going to discuss the basics that basically everybody knows, but we're also going to dive into something that most people have probably never heard of. In fact, it was something I hadn't really heard of until doing research into this presentation. But there's a really cool, I guess you could kind of refer to this as a hack. I don't really like using that term, but it does kind of qualify as a hack versus just something that you're going to be able to increase, X food in your diet in order to get the benefit from. When we look at the mouth, we can see that it is effectively the doorway through which bacteria enter our digestive tract. And we're getting this primarily from our food and through the air we breathe, but it's also important to point out that a lot of them are just going to set up camp within our mouth, and this is what's going to create the oral microbiome. And this oral microbiome is huge. It's the second most diverse and populated site in the human body, next to the colon. There are over 700 species of bacteria, and at any given moment there are approximately 20 billion bacteria and other microbes within our mouth. Candida albicans, well-known yeast, is another inhabitant of our mouth. But as a consequence of this, throughout the day, we are going to swallow approximately 1.5 trillion microbes per day. Some of these are coming in our food, the water we drink, the air we breathe if we're breathing through our mouth, but a large number of them are simply going to be microbes that are inhabiting the oral microbiome that we swallow in our saliva. And when we drink water, even, you're drinking water, even if it was completely distilled, bacteriostatic water, it's going to rinse your mouth of the microbes that make up your oral microbiome, and you're going to swallow them. The assumption has always been that the stomach eliminates transmission. So in the mouth, we should have a more, kind of neutral pH. And this allows our carbohydrate digesting enzymes and lysozyme to kind of break down carbohydrates and kind of attack bacteria that we don't want in there. But the thought has been that once whatever enters our mouth hits our stomach, the acidity basically eliminates everything. But it's important to point out that even if 99.99999% of microbes are killed within the stomach, that's going to leave 15 million that make it through every single day when we're drinking water, when we're eating, or when we're just swallowing our saliva. So you can get the picture here that the oral microbiome is really, really important, and there's a pretty good chance that we'll discuss data on later that what is in our mouth is going to find its way into the other sites of our gastrointestinal tract, including our esophagus, our stomach, our small intestine, and our colon. So now let's just kind of take a look at how oral health plays a role in the gut and how it may modulate our microbiome or the way that our digestive tract works. As I mentioned, the mouth is where things enter our body, more specifically our digestive tract, which is outside of our body. But these microbes and nutrients, as well as metabolites that are generated from microbes, are going to interact with our gastrointestinal barrier and regulate things such as our immune system, inflammation, which microbes are going to crowd out, which microbes they may want to team up with. So this is a really important kind of site to be focusing on, the oral cavity. We get the secretion of antimicrobials, including lysozyme and immunoglobulin A. The mouth is also the first site where we start breaking down starch through salivary amylase, and the pH within the mouth is typically neutral between 6.7 and 7.3. This is really important because amylase, the starch digesting enzyme that works in our mouth, does not work well under acidic conditions. So for example, if you eat something starchy with, say, a pickle or something with vinegar, it's actually going to inhibit the breakdown of those carbohydrates in the oral cavity. We also have mechanical breakdown. We're chewing, we're breaking things up, we're basically making our food into what is called a bolus. This is accessing the inner parts of the food so that the digestive enzymes can break it down. And it's also the first layer of microbe selection. Granted, we have the lysozyme and the immunoglobulin A. The things that live in the mouth are going to live in the mouth because they are kind of working with the environmental conditions of the mouth, the pH, the antimicrobials, and this is going to select for bacteria that are appropriate to live in the mouth. It's important to point out, though, that you can circumvent this. Things such as, eating like a kind of a more garbagey processed food diet, eating throughout the day, not breaking up with meals, not brushing, flossing, things of that nature, are going to cause overgrowth of potentially pathogenic bacteria. And even if it's commensal organisms, you really don't want to have an overgrowth of bacteria in your mouth, even if they are the good guys, because they're going to be accessing the rest of your gut. As we mentioned, it was pretty much believed that the stomach was going to eliminate any significant transfer of microbes from the mouth to the other parts of the digestive tract, but we've actually had a couple of pieces of evidence that indicates that this is not really what is happening at all. This first paper, quantitative sequencing, clarifies the role of disruptor taxa, oral microbiota, and strict anaerobes in the human small intestine microbiome. And basically what they found in this paper was that 89% of the microbes found in the mouth were also found in the duodenum. They were there. They were setting up camp. They were also setting up communities to regulate, the digestion of our food, things of that nature. There were specific taxa known as disruptor taxa. Now, what this meant is when these microbes made their way into the small intestine, they disrupted the small intestine, specifically the duodenum, and they displaced commensals and led to the overgrowth of bacteria, which is super interesting if you're thinking about things like SIBO. If you have this transfer of disruptors from the oral microbiome into the duodenum, you get a high microbial load, and people with SIBO actually have a higher level of these disruptors, and of course they have a higher level of bacteria, SIBO being small intestinal bacterial overgrowth. So here we're seeing where we're getting transmission from the mouth through the esophagus and stomach into the duodenum, and if these disruptor taxa get there, they're disrupting the microbiome in the duodenum, and they can lead to things such as SIBO. They could also kind of modulate the environment within the duodenum, making the pH a little more acidic than you would want it, and they could kind of have a negative effect on how well enzymes and bile are functioning within the duodenal microbiome. So here, 89% is a lot. So basically 9 out of 10 organisms that inhabit the mouth also inhabit the duodenum, and these are transferring from the mouth into the duodenum, and they're setting up camp. These are not just like dead bacteria floating around the duodenum. This is effectively live transfer of microbes from the oral microbiome to the duodenal microbiome. And just kind of a little a side note here, this isn't really in the paper, but if we're building this very acidic oral cavity, which is going to breed more acidic tolerating bacteria, these are going to be more likely to make it through the acidity of the stomach and into the duodenum. Both the oral cavity and the duodenum are meant to be more neutral in pH, even slightly alkaline. And so if we kind of eat tons of sweets, the sugar gets fermented into acids. That erodes our enamel. But additionally, this may set up these disruptor taxa to move more effectively from the mouth into the duodenum because they are acid tolerant. So we might want to look at generating more alkalinity in the mouth to kind of cut back on the number of bacteria that make it from the mouth into the duodenum. We also have evidence of oral to colonic transfer of microbes. This paper, extensive transmission of microbes along the gastrointestinal tract. What they found was that 40% of the microbes that they sequenced were found in both the mouth and the colon. So you could get oral to colonic transfer, or you could get vice versa. That would be, probably, not you specifically transferring microbes from your colon to your mouth, unless you're not washing your hands when you go to the bathroom, but maybe, colonic microbes finding their way into the water system and the food, et cetera, et cetera. And within individuals, 75% of the microbes found in the mouth were potentially transmissible. This was up to 99%. There was a lot of inter-individual variability here. This is simply going to be the individual personalized nature of the microbiome. Certain individuals are going to be able to transfer more from their mouth to the other sites of their gastrointestinal tract. You're not going to see a lot of similarity between individuals, but within an individual, you're going to find a higher transmissibility of microbes from the mouth to the colon. So the findings of this paper is that there is actually extensive transfer from the mouth. If you look at the last paper, we're looking at the duodenum. It only needs to make it through the stomach. Here, in addition to making it through the stomach, these oral microbes are going to be exposed to bile acids to a greater extent than the ones that were found in the duodenum. So they're going to more often than not be more bile resistant unless the individual has some impairment in their bile flow. So how can we improve oral health? Well, first and foremost, you want to brush regularly, get your regular cleanings. The regular cleanings are really important because they're going to be breaking up any biofilms that form over time. Even with regular brushing is not adequate. Of course, you should be flossing and potentially even using something like a water pick. But even if you're brushing 3 times a day and flossing, you're still going to get an accumulation of plaque. So you'll want to have that removed, every 6 months. But when we are looking at the brushing regularly, this actually has a pretty robust effect on decreasing the microbes that move from the mouth and beyond. A paper that we discussed in a blog found that people who brushed 3 times a day had 10 to 100 times less Candida albicans in their stool samples compared to people who brushed only 1 time a day. It's important. If you brush after every meal, you're going to knock back that bacteria so that they're not going to proliferate and have too much bacteria in your mouth at one time. So clearly, if you're going to be brushing regularly, it's important to also cut back on snacking. If you're eating all day long, you're exposing your teeth to food, especially if these are high sugar or high carbohydrate. You're going to get more of that acidic bacteria. You want to wash that away. So sticking to 3 meals a day, brushing and flossing after every meal should help knock back some of the microbes. You can also rinse after meals to restore pH. This is probably important. There's going to be certain situations where you can't brush right after you eat, and you probably shouldn't do that anyway. You should kind of give it a little time. So rinsing your mouth after meals is important to kind of rinse that acid and some of the bacteria from your mouth and just kind of get it away, wash it away, so that it is not going to kind of expand to higher levels. Finally, there's a really interesting paper, a series of papers that have been coming out over the last 6 or 7 years, looking at the amino acid L-arginine or arginine. So arginine is an amino acid that we use. It's used extensively in us to make nitric oxide, which is something that relaxes our blood vessels and kind of lowers blood pressure. But it's been found that it actually also disrupts biofilms. It does this through multiple mechanisms. For one, it improves the oral microbiome. It decreases the number of acidic organisms within it, and it increases the pH. That's because bacteria have this system called the arginine deaminase system, which breaks down arginine and eventually leads to the production of ammonia, which increases pH. It makes it more alkaline. So by doing this, increasing the pH is going to knock back on those acidic organisms. It's going to improve remineralization of teeth. Remineralization of teeth generally happens at a pH above 5.5. So when we consume things like, say, alcohol or sugary drinks, the bacteria are going to knock the pH down into a more acidic pH, and if it drops below 5.5, we're going to be, again, losing calcium from our teeth. So if we rinse or use products with L-arginine in it, then we will actually lower the pH, improve the oral microbiome, and help remineralize our teeth. Interestingly enough, too, this has a systemic effect on us. Using arginine increases species that reduce nitrate to nitrite. This is kind of a process that we outsource to our microbes that we really don't do anymore. So this actually leads to the production of nitric oxide, which we previously mentioned. And so when we consume nitrate in our food, if we have a high number of these species that break down arginine, we're going to also have a high number of species that reduce nitrate to nitrite, and then the next step in this process is to convert nitrite into nitric oxide, which we do. So having a high number of these bacteria in our mouth and throughout our gut can actually help keep our blood pressure within healthy levels. That wraps up this presentation on the importance of the oral microbiome and overall gut and digestive health, and how this plays a role in transferring microbes throughout the digestive tract. Hope you enjoyed it. As always, if you liked this, like it on YouTube, share it on YouTube and social media, and don't forget to subscribe below. This is the only way that you can be sure to get access to all of the videos that we produce as soon as they're released. We also release them on the blog, so you can check it out there. Sometimes we give little extra tips and things and refer to other blogs that we've already written on these topics. So thank you very much. Again, if you like it, share it on social media and on YouTube. If you have any comments, questions, or constructive criticisms, please put them in the description below. Thank you very much, and take care.